So we tested out a BERT model, a RoBERTA model, which is more robust, and an Electra model, which should be better fit for small resource languages. But yeah, the only thing you need to remember from this slide is in fact that the BERT model with the biggest data set, so including modern Greek, worked best. So,
sense of size.
Sorry?
Just the question is size of the data sets.
The biggest data set had 127 million tokens.
So,
yeah. Yes. So just some numbers for the part of speech tagging. So it's quite easy. We pass a token through the pre-trained BERT model. Then there's a classification head, which in this case provided us with a part of speech. And the model yielded some 82% accuracy, which was very similar to the pilot study my colleague Pranay Singh did. And was quite a bit better than the RNN, the existing model, and a frequency baseline we computed. But then we tried the same for lemmatisation, which was horrible. So again, we passed the token through the pre-trained BERT model. We fine-tuned the classification head on lemmatisation, and we tried a lot of different setups, and only a hybrid setup performed better than the worst performing existing lemmatizer. So it's hybrid because we made a dictionary of closed class words. And if the to be tagged token was in the dictionary, it returns the lemma of the dictionary, and otherwise the model predicted the lemma. So that's why we needed a solution. And last summer, I enjoyed myself trying out to train a multitask head on the DB-BERT model. So instead of doing both tasks separately, so just fine-tune the DB-BERT model for lemmatization and fine-tune it again for part of speech tagging, we now did the fine-tuning of both tasks simultaneously, with the idea that it would exchange some information which might be beneficial for the two tasks. And it was. So for the lemmatization task, we had an accuracy of almost 80%, which is some 8% above the best performing existing lemmatizer, and more than 20% above our best model. But what was very nice to see is that also the part of speech tagger improved a bit. It was only with 2%, but it was nice to see that really both tasks were beneficial for one another. So that's what the little piece of code will be about that I will show you. But for completion, I will first finish my slides with a case study for why this information is interesting for similarity detection. So here again is the Wolfsburg-Seni epigram. I only displayed the variant with 2 verses, but the epigram can take up to 5 verses, and every verse is in a box. This is the first verse, this is the second verse, so that's the biggest group, the last verse, I'm sorry. And these come in between. But the green box is a bit special because it's also the last verse, but some of those display a dative case instead of a nominative case. And with a Liebenstein distance of 85% similarity, they are seen as a separate cluster, which is okay, but it's not what I would want to see if I'm looking for like all the verses similar to the last one, just because the dative case makes it a bit different. So if we then compute also the Liebenstein distance between all the parts of speech of the verses, and we then make them equally important for the final computation, we get these clusters. And then you see that the dative verse, the green box, is included in the cluster of the last verses, which is, for me at least, a bit nicer. I was very happy with it. Also, the clusters are a bit bigger. There are less loose nodes in the picture. So this is a more relaxed version of the simple orthographic Liebenstein, which we already did. And then the semantic similarity is something we're working on at the moment. So just to make the picture complete, this is still work in progress. So we're annotating a gold standard, which is very hard because there's no right or wrong with similarity and ranking. We're looking at similarity on word level, and then how we could average it for the embedding of the verse, and then we will also look directly on verse level, but then we will need to train another BERT model that is not token based, but verse or sentence based. And then the idea is to compute the cosine similarity between two vectors to get a similarity score. But as said, this is still a work in progress. So this was the presentation until now. Are there any questions already, or? Or should I first go to the code? It's how you like. Yes.
I did have a question about the clusters. How did you use a clustering algorithm?
Yeah, this is just a visual. So the project contains 4 PhD students. One is working on manuscript culture, then the one working on formularicity. I'm working on language technology, and then we have Maxime, who is an engineer working on the creation of a graph database. And he has put the set of all Hospexeni verses in the graph database, and then computed the Liebenstein distance between first the words and then a level higher between the verses, and that's how we got this. So he asked to group them if they had a similarity score higher than 85%. So this is just a visualization of the graph database after its computation. And then he did the same, but then with 2 similarity scores combined, and they were just equally important. So both the orthographic Liebenstein and then the Liebenstein between the parts of speech, which made it a more relaxed version of the Liebenstein distance. But it's also just a visualization of the graph database. Yeah. So the code is not yet on my page of Hugging Face. It will be available if I cleaned it up a bit more, but I will already show you. So I don't know how familiar everyone is with training or fine-tuning a model. So I will just go.
No, so
Okay, so I will just go over some steps, but a bit more in general, and then at the end, so the multitask thing is happening just in the computation of the loss and the update of the weights. But I will just go over it a bit more high level. So let's start at the left side of the screen. So we first just define the path to the data set and a model. So it's the most famous model in the world, TB-BERT. It's tokenizer, and then you make a set of your tags. You read the data set, which needed a specific format. So I wrote then the ancient Greek data set class. You load the data, you count the number of labels for part of speech tagging and lemmatisation. And you also create the mapping because the label is not written as noun, but it just gets a numerical value. So you store that in a dictionary or something. It's also nice to save them, in this case in a pickle file. Then you define the model and its variables, the optimizer, the number of epochs, the branch interval, etc. The loss that will be used. And then here starts the multitask part. So I put the split screen on because there are 2 ways to probably maybe more ways, but we tested out two ways of multitask learning. So you can do it simultaneously or alternately. And in general, it's said to use simultaneously training if the tasks are very similar to one another, and alternately if they're a bit further away from one another, which was quite abstract for me. So we just tested out both of them. And the scores were very similar. So I thought simultaneous training was a bit easier. So for this task, this is my preferred solution. I'll start with that one because it's also easier to read, I think. So what you do is train a model on both the part-of-speech labels and the lemma labels. So it outputs on the last layer always the part-of-speech and the lemma labels. And then you compute the loss of both part-of-speech and lemma, but also their total loss, which is then used to update the model again. The difference with the alternate training on the left side is that you switch per batch. So for one batch, you only train on one task. So let's say we start with part-of-speech, and then the lemma head is frozen, and then the loss is computed for only part-of-speech to start with. And then if you compute the loss, only the part-of-speech loss is taken into account. For the next batch, the part-of-speech head is frozen, and then you only train on the lemma head, and then the lemma scores are used to compute the loss and update the model again. So it always switches per batch between the two tasks. We are now thinking of doing this for morphological analysis as well, because we had very bad results on morphological analysis. But that will be something for January if we have a bit more time. And then, of course, don't forget to save the model in the end, because it would be a waste of training hours. I think I can show you the inference as well. Or is it here? Or is this just the testing? Yeah. I don't know. Are there any more questions on the code? Because I can give some more details, but I don't know. I used two GPUs and it took 2 days to fine tune. 2 days for the alternate training because it takes longer. The simultaneous one was, I think, one working day and then the night over, and then I could see the results in the morning. It was quite okay, I think. Also, the fine tuning, I didn't give all the details. The fine tuning was done on classical Greek data because we did annotate the gold standard ourselves of the occurrences of DBBE, so on the inconsistent data, but we didn't have enough data to also train on it because we need test sets of our data. So everything is trained on classical Greek data from edition. So the ancient Greek dependency tree banks are included. The tree banks from Leuven are included. So for the moment, we were quite happy with scores because it's kind of domain adaptation because we're training on another kind of Greek than we're testing on. But yeah, we keep annotating to hope that we can retrain it or fine-tune it again with some more inconsistent Greek data. But yeah.
It looks like you're importing data from a PSV file, which was a surprise to me. Can you show us a little bit of that? So you have this what sort of scraping from?
No, it's the data. Wait, I think I have the TSV file here. Or just an example.
Already quite a big TSV file, I think.
Yes. So what we had. This is the test set, but yeah, the training data look the same. It's just the token, the part of speech, and the lemma. So for the tree banks, I just extracted them from the XML file. And then
So the XML is where the original source material is.
yes, for the tree banks, it was yeah, our annotations, it was most easiest to just do it in Excel. So I made an Excel with all the tokens of the evaluation set we wanted from DBBE. And then we just started annotating with 3 people. I think we have 10,000 tokens in the evaluation set. Yeah, it was the fastest and easiest way, I think, to annotate. And it was quite easy to read in and then to change the format for the data set because we then needed the Hugging Face datasets format. So for me,
this kind of annotation that didn't exist previously.
not of this kind of data, no. I know I annotated some tree banks myself when I was still a student in Leuven, and then there was like the Aretusa platform. It's also very nice, and you really have a visual of the syntactic trees. And I would have loved to have that from the DBBE as well, but there are no sentences stored in the database, so the units within the relational database that we have now are words, half verses, and epigrams, but there are no sentences. So yeah, we tried a bit out with syntactic parsing, but it was impossible without sentence boundaries. So yeah, but I think it's the first set of unedited Greek. I know Trismegistos, which stores papyrus Greek, also contains the original forms, but I think, if I'm not mistaken, that Alec, who worked on it, put the normalized forms also in the XML code, and I think he worked on the normalized forms. But yeah, it was a bit basic, but it worked. So.
More details on the code?
So the dataset is also available on my Hugging Face page and the model, so the bird model itself and some fine-tuned models as well. And I think we will keep continuing that, so everything is there. If you just look for DB birds in Hugging Face, you will find a page. And then we will make it the most famous.
There are other ancient Greek bird models on Hugging Face, I think.
Yeah, if you
right?
look for ancient Greek bird model, you find the model of my colleague, of Pranay Singh, who did a pilot study the year before I started the PhD. Yeah, the biggest difference is that he started from a modern Greek language model, so it cannot take into account it just gives an error if you want to include diacritics or accents and spiritus and stuff. So that's why we trained the model from scratch, because we wanted to include the diacritics.
There are no other ancient Greek models.
I found one of Brennan Nicholson, I think, but it has not been published like in a paper. It's on someone's GitHub. I think it's from a master's thesis. But I did not try it out because it was developed to fill lacuna in texts. So it was just it's very nice thing, but it was predicting some morphological endings or stems in Greek texts. While this was trained for classification tasks. Any other questions, remarks, feedback?
Have you tried static embeddings?
I'm working with static embeddings now for the similarity, so I'm now looking into similarity between tokens because of another side project, and they work quite well, to be honest. I was working with continuous bag of words, and it worked quite well. I was a bit surprised, but to find similar verbs, it worked quite well, yes.
Silvia Stopponi and Nilo Pedrazzini and I, and Silvia Stopponi supervisors published a paper, Natural Language Processing for Ancient Greek, Advantages, Challenges of Language Models. It came out in Diachronica this year.
Okay.
Be interesting to have a more systematic comparison with BERT models.
Okay. Okay, we'll have a look into that, or if you could share it, maybe.
Yeah, it's open access, and it's can share it with you. I can post it in the chat as well.
It would be nice. Thank you. Any more questions?
Maybe, I don't, ancient Greek is clearly not my field at all.
Okay.
Very broad question. What is the era of language? Sorry, what period does the material cover? Quite large.
The material I'm working with is from the 5th up until the 15th century.
Right at the beginning.
No, so it's starting at the 5th century AD.
Okay.
So it's 10 centuries, yes.
How stable is kind of semantic meaning over 1,000 years?
That's a good question. I did not inspect that at all, so no clue.
Okay. Yeah.
My feeling is that it not changed a lot for this corpus, because the biggest part of the corpus is about our epigrams on religious texts. So I think it might be quite stable.
Yeah.
But it's my opinion, so I don't know. I didn't check. Yeah, I don't think it changed a lot in those 10 centuries. For specifically our corpus,
Yeah.
It did change a lot if you compare it to classical Greek, though. That's for sure. But within the corpus, no. I think the biggest change is the orthography, because the more you go to the 15th century, the more present the itacism is. So a lot of 5 vowels or diphthongs change to an E sound, and it's very clear that the scribes did know which E sound to write. So it's all over the place, which is funny for a linguist. Computer says no. But I think the colleague working on manuscript culture will look more into detail into meaning or change of meaning in the corpus. Yeah.
This is a question like on the project in general. So are you also looking at, in a qualitative way, you're also looking at these kind of mistakes, like which words mostly occur with a mistake and why? Because I saw there were like different kinds of mistakes in your slides.
Yes.
There was Idin and there was Kerondes.
Yes.
So I think it was, yes.
Here, for example.
I think it was the other one. You had this one.
This one?
So yes, you had Erosin and then Kerondes, so I and E and then Idin.
Yes.
And then Vibliu with Upsilon, which is a bit weird. So are you also like trying to get explanations for this kind of mistake? So why is it? Are you also counting? Also another question. So are you also counting, for example, I don't know, looking at the fact that usually Idin is written in a wrong way, and why and how?
I'm not looking into that. That will then be more for the linguistic PhD students. I don't know whether she's looking into that or whether there's a good explanation for it. No clue. It would be a nice qualitative study, I think, for the project to see if it's scribe related. Does one scribe make a lot of mistakes, or is it because he has a bad day or a good day, or I have no clue. No, we're not investigating that at the moment, but it might be a nice addition to the project for future PhDs or postdoc students. No, we're not looking into that. Yeah, for me, it all made sense from.
Yota is very good to look at. So I mean, same with Ita made sense, but same with Yota.
Yeah, for me, it all started making sense when I learned new modern Greek during the PhD, because in the beginning I was like, what am I reading? But then the moment I learned modern Greek, everything made sense. The annotations went way more smooth than before. But yeah, it is interesting. Maybe after I hand in the PhD, it would be something nice to do in summer or something. Start counting it, and we'll see. But it's a good suggestion, yes. I hope everything was clear as well, because I don't know what your backgrounds are.
Yeah. So it's a bit late to find out about my background. Who is working on ancient Greek here? Half. Half a hand. Who is working on ancient Greek online?
I would ask some colleagues as well.
Yeah. It would be, yes. The project is also ending within a year, so then we have to look for something else.
Okay. Are there more questions online?
Thank you for coming.
Yeah, apologies, the recording started late. Sorry that Dania, you had left a message correctly. It slipped my mind, so I started 15 minutes into the talk. Yes, my mind was elsewhere. Too focused on the talk. Okay, so if there are no more questions, would you like to say more, show us more, or are we?
No, if someone would have questions afterwards or want more detailed explanation, just send me an email.
Did you start? Did you write the code from scratch, or did you start from?
I looked for examples, and then I tried to combine them. And luckily, there was Copilot to help me out when I really was stuck. But yeah, there wasn't a lot online, so that's why I thought it might have been interesting to show it today a bit.
Yeah.
And it will be at my Hugging Face. I would say in some weeks, but in January for sure, because I have a bit of holidays now. But then it will be accessible. So,
how different do you think it is with other languages if you translation, etc. The actual code?
Oh, it's a good question. I think it would be Sorry?
You were saying you got some help with prompting.
Yes.
Yeah, and that worked.
Yes, but it worked quite well because I gave it quite specific questions. So I did the thinking myself, but then it was for specific parts like the alternate training, how to structure it best, because I knew which steps I needed to do, like the computation of the loss and use the how do you say it in English? The even and uneven patches, like that, yeah. But it was handy then to have Copilot's help to structure it the right way. But it went quite well, yeah. I also think if you want to change something for another language or like for a similar task or add one task, that you have like 3 tasks instead of 2, it will be clear enough, I think, to do it yourself, but I think you can easily ask Copilot or ChatGPT to help you with that as well.
So let's thank Colin and yeah, for now. Thanks everyone. I will be circulating the link to the video recording, even though it wasn't complete, and also a survey to everyone. Hi, Els. Nice to see you. It was great talk. Went very well. Yes, I'll circulate a survey about the group to everyone who's subscribed to the mailing list. So if I don't see you, Dania is happy. Great. If I won't see you, of course, this is the last seminar before the holidays. I'll see you next year. Okay, bye everyone.